Welcome. Think about a time you sat at a desk and studied for hours. Your brain was tired, you felt exhausted, and you definitely felt like you were working hard. The universe has a stricter definition. In physics, sitting perfectly still means zero work is happening. You can spend all your mental effort on a problem, but if nothing physically moves, it doesn't count toward the total. To count as work, two specific things have to happen. First, you have to apply a physical force, like a push or a pull, to an object. Second, that object must change its position. If you push a heavy block and it slides across the floor, you've met the requirement. We calculate the result by multiplying force by distance moved. The answer is measured in joules. Without that physical motion, effort is effectively invisible to the laws of science. In this system, work requires movement. If work is the action of moving things, what makes that action possible? To push anything, we need a specific kind of fuel. We need energy. Think of energy like a universal bank account. To move, lift, or push an object, you have to make a withdrawal from that account to pay for the motion. When you do work on an object, you are actually transferring that currency into it. Your account goes down, and the object's energy goes up. One way an object holds this energy is simply by moving. A vehicle speeding down a track has what we call kinetic energy. Because the vehicle is in motion, it carries the ability to do work. If it hits an obstacle, it spends that kinetic energy to push the obstacle out of the way. But objects can also store energy for later. By changing an object's shape or lifting it up high, we give it potential energy, fuel that is waiting to be used. Look at this drawn bow. As the string is pulled back, the effort is stored in the string's tension as potential energy. The moment it's released, that stored tension vanishes, converting instantly into kinetic motion, launching the arrow. This illustrates a hard rule. Energy cannot be created or destroyed. As this pendulum swings, it loses height but speeds up. One form of energy turns into the other, but the total amount stays exactly the same. The universe operates on a fixed budget. Energy simply changes its appearance, while the total amount in the system remains constant. To power our world and do the massive amounts of work needed for modern life, we have to find where the planet stores its energy. Fossil fuels like coal and petroleum are essentially ancient solar energy. It was trapped in living things millions of years ago and then squeezed deep underground. These are non-renewable sources. The Earth takes millions of years to create them, but we can burn through that entire history of energy in just a few generations. Contrast that with renewable energy. These are sources that the environment refills naturally every single day. Instead of mining ancient reserves, we can capture energy from the sun's rays, the push of the wind, the pull of the tides, or the heat rising from deep within the Earth. Our progress is defined by how well we can find these sources and transform them into the work that keeps our cities running. To see these rules in action, let's look at a practical example. Imagine a machine lifting a heavy supply crate vertically. First, we calculate the force needed to lift it by multiplying the crate's mass by the downward pull of gravity. Then, we multiply that force by the height lifted to find the final work performed, measured in joules. Now, imagine two different machines doing this exact same task. They both lift the same crate, but one machine finishes in half the time. Though the total work is identical, the speed is different. This is what we call power. We find it by taking the total work and dividing it by the time it took to complete. Power is measured in watts. 1 watt simply means that 1 joule of energy is being transferred every second. Work is the physical action, energy is the currency that pays for it, and power is the speed of the transaction. These equations define the invisible limits of our world. They dictate everything from how a single box moves to how an entire city stays powered. Physics provides the blueprint for how we interact with the world. By measuring work and managing energy, we can build more efficient machines and better ways to power our lives.